Hello student, welcome to my channel IIT Forum. Myself Parth Chaudhary. So today's lecture is basically based on resonance. So in this lecture series, that is a fundamental organic chemistry, I have discussed about three topics already. The one was a dipole moment, inductive effect, and the last one was a intermolecular forces. So this is a fourth topic which is very vital and very important topic for organic chemist and for anyone who want to learn chemistry. Okay, so guys, I'm gonna discuss about this basic of resonance. Okay, so I'm not gonna discuss about this brief history about resonance. So that is why, because to discuss about brief history, I have to discuss about VBT, that is valence bond theory, and Lewis dot structure. So I'll make a different video on this topic, that is the Lewis dot structure and valence bond theory. So let's start about this basic of resonance. So guys, what is resonance? So resonance is nothing but a delocalization of electron. Okay, delocalization of charge, that is a resonance through the bond. Okay, so guys, before start resonance, I want to discuss about this type of bonds. There is a three type of bonds is generally in chemistry. One is a sigma bond, one is a pi bond, and another is a delta bond. So one is a sigma bond, one is a pi bond, and another is a delta bond. So delta bond is very different, so you don't need to learn right now. So if you want to learn, please make comment in my comment box about this. I'll make a different video on this. Okay, so in this video I'll discuss about sigma bond, pi bond. So guys, how sigma bond will form? Generally, there is a s orbital, p orbital, d orbital, f orbital, and so on. So s orbital, that is a in s orbital, 2s orbital, if head on head overlap, okay, head on head overlap, they will form sigma bond. Okay, they will form a sigma bond. And if 2p orbital in head on head overlap, it will form also a sigma bond. Okay, so that is how sigma bond will form. Sigma bond will form by head on head overlap, but pi bond will form, this pi bond is formed by side by side overlap. Okay, this side by side overlap, this pi bond will form. Okay guys, so I think you have some idea about sigma bond and pi bond. So why I am discussing sigma bond and pi bond, you will know. Okay, so let's start. Let's take an example for better understanding about the sigma bond and pi bond. So the molecule. So let's change the color. Is the ethane, that is CH3, CH3, CH3. Ethene, that is CH2, CH2. Acetylene or ethyne, that is CH triple bond CH. Where in the sigma bond, this is a single bond. Okay, in this structure, that is ethane has a one sigma bond only. Okay, and how the sigma bond look like? So let's do this orbital structure. 2 carbon is head on head overlap. Okay, so let's change the color. Here 3 hydrogen, 3 s orbital, 3 hydrogen will head on head overlap also and form a sigma bond. Or this is a sp3 hybridized. Okay, so this is a this is a sigma bond. Okay, and then what is the pi bond? So let's draw another structure of ethane. Okay, this C, another C, okay, so let's change the color. So here this is a sigma bond, right, sigma bond, and here this 2p orbital will side by side overlap and form a, this is a pi bond, this is a pi bond, and this hydrogen with this carbon atom. Okay, so this is a pi bond, and let's discuss about this last structure, that is a acetylene, that is C triple bond C. Okay, so 2C. So there is a p orbital, you know, px, pz and py orbital. So let's draw the structure first. Okay, okay, so you know, this is a, this take is a p x, this is a p y, and this is a p z. Okay, so this head on head overlap is a sigma bond, right? This px, another px orbital will overlap. Okay, these two orbitals overlap and form a pi bond. Another, this py orbital is overlap with another py orbital of another carbon and form a another pi bond. So in triple bond there is a 1 sigma bond and 2 pi bond, right? 1 sigma bond plus 2 pi bond will form a triple bond, right? But in double bond there is a 1 sigma bond plus 1 pi bond, right? Form a double bond. But in single bond there is a only sigma bond are there. Okay, so I think you have an idea about this sigma bond and pi bond. So let's go to this resonance structure. Okay, so why I discuss about this sigma bond and pi bond, so you will better know if I take an example with it. Okay, so let's an example CH2 double bond CH single bond CH double bond CH2. Okay, so why I take this example, I'll discuss. So basically, what is resonance, right? So you know what is sigma bond, what is pi bond. So keep the thing in mind, in resonance only pi bond will contribute, means pi bond delocalization will be happen, no sigma bond delocalization will happen. Okay, sigma bond will still at it is in this first position. Okay, so in how pi bond, so you know this double bond carry, this double bond carry a pi bond, right? And this double bond carry a pi bond. So I'm gonna discuss about which type of structure, which type of compound will contribute in the resonance. So before that, please keep the thing in mind. So you know different type of arrow, right? So let me discuss about this arrow first. So I'll come into this resonance structure. So you know this structure, this arrow is known as this forward arrow. Okay, this is a forward arrow, right? This arrow is a backward arrow, and you know this is a reversible sign, this is a reversible sign. And how can we express this resonating structure? So here is a double headed arrow, you know this double headed arrow is known as double headed arrow, which indicate this canonical form. And what is this canonical form? Canonical form is nothing but a resonating structure. So when you draw the different type of resonating structure of a same molecule, you have to use this double head arrow. Okay, so now this is a best position to come into resonance. Now you know this sigma bond, now you know this pi bond, now you know this what is the double headed arrow, how can you represent this resonance form with arrow. Now let's come to this structure. Okay, this compound CH2 double bond CH single bond CH double bond CH2, right? So what I told you only pi bond will contribute in a resonating structure. So let's let's write down or jot down some notes, some tips and some tricks about which type of compounds will show resonating structure or will contribute in a resonating structure. So guys, take an example first. Okay, number one, so you have to keep in mind that this type of arrangement are there in a structure or not. So only this thing you have to keep in your mind. Okay, so if you see pi, sigma and pi combination, then it will definitely form a resonating structure. Number two, if pi, sigma positive charge, then it will definitely contribute in a resonating structure. Number three, pi, sigma negative charge. Number four, pi, sigma lone pair. Okay, so if you found these four type of thing in a compound or in a molecule, so you can draw resonating structure from this compound. Okay, so here first I have a example, right? So let's solve this example, okay, with different color, so it will be easy to understand. So before start resonating structure, so you know this sigma bond, you know pi bond, you know double headed arrow. Okay, so but one last thing you have to know, you have to break down this pi bond in your mind, not in your note. Okay, so please don't write this type of structure in your exam hall, but it is for your imagination. Okay, so let's start. What is for your imagination? That is CH2, right? Single bond CH, single bond CH, single bond CH2. First break down this pi bond. This pi bond is nothing but a positive and negative charge, right? It's nothing but a positive and negative charge. So if you put here one positive charge, one negative charge, so you know this positive and negative charge will combine to each other and form a bond, right? Similarly here is a positive charge and negative charge, right? So this thing, this structure you never write in your exam. Okay, this is for your imagination, this is for your understanding. Okay, so guys, you know here one is a positive charge, here is a negative charge, here is a positive charge, here is a negative charge, right? So you know this negative positive can combine, right? So this is a arrow, that is double headed arrow for canonical structure or resonating structure. So you can definitely write CH2 single bond CH, this negative and positive will form a bond, so it's a double bond CH single bond CH2, and you know this has a some charge, that is a positive charge and this is a negative charge, right? Right or not? I think it's right. Now you can draw another resonating structure from this, okay, which is nothing but its original structure. So if you put this negative charge and this positive charge, so first thing you have to do in your mind, so don't put this type of structure in your exam, this is in the box, right? And this one and this one, you can write this one in your exam. Okay, so let's CH2 single bond CH, you have to break down this double bond, okay, and form one negative charge, one positive charge, and here also CH2, that is negative charge, and here also positive charge. Now you can remind this same thing, so same thing is here also. Okay, so these two positive and negative can combine, this positive and negative can combine and form a this original structure, right? That is CH2 double bond CH, single bond CH, double bond CH2, right? Is that right? I think it is right. So that is a resonating structure. Okay, so if you have any problem, I think you don't have any problem here, because you just have to keep this box, okay, this box in your mind. So if you find this pi sigma pi, pi sigma plus, pi sigma negative, pi sigma lone pair combination in any structure, so this structure will definitely form a resonating structure. So in here which type of combination, which type of thing you can see here. So here is a, that is a pi bond, okay, that is a sigma bond, okay, that is a pi bond, right? So pi sigma pi, so pi sigma pi is here, so this will definitely form a resonating structure. So I just want to want to discuss about this. I just want to understand about this thing, okay. So you understand or not? So this is the example, that is why I put an example for your better understanding about this example. So now you find this combination, so let's discuss about this combination, okay. So how this combination will help to this resonating structure. So okay, so if you take an example like CH2 double bond CH single bond CH2 plus, okay. So here is a pi bond, here is a sigma bond, and here is a positive charge, right? So you found this combination here, right, in number 2. So will this structure will contribute to the resonating structure? So let's see, okay, let's see it is form a resonating structure or not. So you know this is a positive charge, okay. So in your mind please break down this pi bond and form a one negative and one positive here in your mind. So don't put this type of structure in your exam, in your mind, okay. So you know this negative charge can combine with this positive charge, right, and form a double bond, and here one positive charge will still left. So let's draw the structure. CH2 single bond CH double bond CH2, here is a positive charge, right or not? This positive charge still remain, and this negative charge and this positive charge will combine to each other and form a new double bond, okay. So this is also a canonical form or resonating structure of this compound, right? So you can practice in your home. There is a number 3 and number 4, that is these and these, it will work or not. So just make an example by yourself, put one pi bond, one sigma bond, one negative, and draw the resonating structure, okay. So this is the main concept, this is the basic concept of resonance. So this is how you can, I can guarantee you, if you remind these four combination, so you can definitely do this resonating structure anywhere. So it does not matter in which level you are, you can have a class 11 level or you BSc level, or you are in a PhD student, so it doesn't matter. So if you remind this type of combination, so you can draw this resonating structure in anywhere, okay. So this is about this resonance, okay. I think there is no problem. So let's discuss something about this stabilization, okay, stability. So discuss about stability, okay, which resonating structure will more stable. So for stability, keep the thing in mind, okay. One thing you have to keep in mind is neutral, okay. Neutral molecule is always more stable than cationic or anionic structure, okay. This you have to keep in your mind, this neutral structure is always more stable than cationic and anionic structure. So you know this neutral is more stable, but how can you compare between cationic and anionic structure? Let's say you have a two structure, one is cationic, what is anionic. So which one is more stable, okay. So let's take an example like one have a CH2 double bond CH single bond O negative, and another CH2 double bond CH single bond O positive, right. So which one? It is a number 1, it is a number 2. So which one is more stable? So guys, you know these both 1 and 2 can form a resonating structure, because you have a combination of, that is pi, that is sigma, and that is negative, right? So these three combination you have. In the second structure, one has a pi, one has a sigma, and another has a positive. So here also resonance structure will form. But which structure will more stable? Which one is more stable? So guys, I would say this negative and this positive charge. Okay, so how this negative and positive charge can be stabilized? If you transfer this negative charge into the neutral one, so it will be more stable, right? Because if you decrease the, if you can reduce this negative charge, if you can reduce the negative charge from its head, so it will stable, and if you decrease this positive charge from its head, it will also stable, right? So how can we decrease this positive and negative charge from an atom? So guys, you know, oxygen is more electronegative, right? Oxygen is more electronegative. So if oxygen have negative charge and one oxygen have positive charge, okay, one oxygen has negative charge, one oxygen has positive charge, so which one will be more stable? So you know, if oxygen is more electronegative, it takes this negative charge toward itself, okay, so it generally it is reduce this negative charge. But if oxygen is more electronegative, if it take this electron from itself, this positive charge is gonna increase, it's not gonna decrease. So positive charge is increasing but negative charge is decreasing. So remember, oxygen is always stabilize this negative charge, because oxygen is more electronegative. So if oxygen have negative charge, and in another example, if oxygen has positive charge, so negative charged oxygen will be more stable than positive charge. Okay, I think it's clear. So thank you guys, this video is up to this. So I'll discuss more about this resonance. If you want to know more about some resonance structure and this example, so please go and put your comment into your comment box and subscribe my channel to get more videos. Okay, so bye guys, let's we'll see in my next video.